Hello students, in previous class we have already discussed about the chapter work and energy. Now I am going to continue with the same chapter work and energy. Today we discuss about idea of energy. The word energy is very often used in daily life in various occasions, like he is more energetic, I am so tired and lost my energy, etc. What is energy? How we can decide that an object possesses energy or not? Let us take an example. Let us see an example. A metal ball kept in a ceramic plate is raised to a certain height from the plate and allowed to fall on it. What will happen to the plate? The plate is broken. Why? You might have observed that metal ball does no work when it rests on the surface of the plate, but is able to do some work when it is raised to certain height. We observe that the capacity of doing work by an object on another object depends on position and state of the object which is doing work. So many types of energies we have. All these energies are it can change from one form to another form. We cannot create energy or destroy the energy. Physics say that energy is neither created nor destroyed, but it can change from one form to another form. This is basis of nature, and this is called principle of conservation of energy. Principle of conservation of energy. Principle of conservation of energy. It says that energy neither created nor destroyed, it changes from one form to another form. Suppose you take an example of hydropower stations where they producing electricity using water from dams. Water is falling from the greater height. They using huge amount of water. The potential energy is converting into kinetic energy. We can see their electromagnetic energy gives electricity to us. Another example, take an example of electric bulb. How does electric bulb work? You obviously know electric bulb using electric energy and gives us what? Light. And another example, if you take electric motor, electric energy is converting into mechanical energy. Another example, electric fan. Electric fan is converting into mechanical energy. Of course, one example, of course, it is converting to some part of wind energy. So, energy neither created nor destroyed. It changes from one form to another. Now we see one important part, that is mechanical energy. Mechanical energy broadly classified into two types, that is kinetic energy and potential energy. Let us discuss about kinetic energy. What is kinetic energy? Kinetic energy is the energy generated when there is a body in motion. When there is a body in motion. Example, a vehicle, or you are walking on the road, or a ball is throwing. These are the examples of kinetic energy. Energy generated when there is a body in motion. Energy possessed by a body due to its motion. So, let us discuss more briefly about kinetic energy. Now, let me derive a formula for kinetic energy. A body with mass m. A body with mass m starting with initial velocity u. Starting with initial velocity u in this direction. And it goes to location, it moves to one location with final velocity v. And displacement s. Some force is applied on it. Force is applied on it. This is our assumption. So, from kinematics equation, v square minus u square equal to 2as. Final velocity, initial velocity, acceleration, displacement. v square final velocity, u square initial velocity, acceleration a, displacement s. Multiply the equation both sides with m by 2. Should not change equation, because equation should not change. M square by m by 2 here 2 get cancelled. M by 2 go inside. MA equal to F, force. F into S equal to W, work done. Here, the body is starting with initial velocity. The body is at rest, starting with initial velocity. So, we can see that we can say that is 0. So, mv square equal to mv square by 2 equal to work done. It is also kinetic energy. So, kinetic energy, we can say that mv square or half mv square by 2 or half mv square. And this kinetic energy, again one thing, kinetic energy and work done is also same. This is the expression, this is the derivation formula we can derive kinetic energy equal to mv square by 2 or half mv square. The formula of kinetic energy. Formula of kinetic energy, half mv square or mv square by 2. Let us apply this formula to solve some numericals. Find the kinetic energy of a ball of 250 grams mass moving at a velocity of 40 centimeters per second. So, mass of a ball, grams. Immediately you have to convert into SI system. How we can convert? We get 0.25 kg. Velocity of a 40. They given the value 40 centimeters per second. We have to convert into SI system. Zero point four meters per second. 0.4 meters per second. So this is mass and this is velocity. So just now we derive a formula for kinetic energy, half mv square. Substitute the values in the formula. Whole square. 0.16. 2 ones are 0.08. If we solve, we get the value 0.02 joules. This is kinetic energy. Now we go to the another part of the mechanical energy, that is potential energy. Potential energy is the energy stored inside the body. Definition of potential energy. The energy possessed by an object of its position or shape is called its potential energy. The energy possessed by an object of its position or shape is called its potential energy. A body is changing its location due to its potential energy. Take an example of rubber band. Initially, if you see the rubber band, after stretching the rubber band, the shape and size is different due to its potential energy. We have another type of potential energy, that is gravitational potential energy. Is the energy generated by a body of its position against gravity. Of a body of its position against gravity. There is a body is lifting up certain height h, and the body have mass due to its gravity mg, and it is equal to force applied on the body. Mass of a body is equal to the force applied on the body. Displacement is h. So here work done. According to work done, force into displacement. Force, we get the value, we know the value, force is equal to mass of an object. Displacement h, W equal to mgh. It is also equal to gravitational potential energy. So gravitational potential energy is also called potential energy. Units are same. SI unit is joule and CGS unit is arc. And it is also equal to the work done. Work is equal to energy. Work is equal to potential energy. Now we apply this potential energy formula mgh. We solve some numericals. This formula to solve this numericals. A block of 2 kg is lifted up through 2 meters from the ground. Calculate the potential energy of the block at the point. Take gravitation 9.8 meters per second square. So, a block with mass 2 kg is lifted up certain height 2 meters given in the question. Now we have to solve potential energy mgh. We know just now we derived potential energy equal to mgh, mass. Acceleration due to gravity g equal to 9.8. Mass 2 into acceleration, we take value 10 and height 2. We have to substitute the values. We will get the value 40 joules. Thank you.